This pen's shit!
Yo, you should try to use a new material.
What?
Use a new material, dude.
For the pen?
Yeah.
Oh. Alright.
Did someone say new material?
Oh my god! Holy shit! Is that here? Professor Gabriel Veridossi? What the legend himself.
Have you kids heard of the new fountain pen nib technology with optimizing material? Well, follow me into my office. Fountain pen nibs are made out of an alloy out of gold, nickel, and copper. And then together, they're heated up to 1,000 degrees. Remember, when heating things up, safety is the #1 concern. So keep some safety tools like a fire extinguisher always at hand. Once you've heated it up, a consistent 14-karat gold alloy comes out. The new alloy is then poured into a mold and let sit for some time. After it's formed a solid solution, we take it out and then we quench it. After the alloy is quenched, it's age hardened at 500 degrees until maximum hardness is achieved. After this, the material is cold rolled, like this, into thin sheets until a thickness of 0.5 millimeters is reached, all while keeping safety a priority. After this, a stamping machine is used to stamp out the shape of the nibs out of the sheets.
Where does the nib go from there?
Great question, Sharkeisha. After that, the nibs are sent out to individual sellers where they can be placed onto pens and sold in stores where you can find them today.
Hey, where'd my girl at? Yo, Sharkeisha! Where you at?
Yo, we could make something totally better than this.
Let's hit on my boy Professor Chirko again.
Good idea.
Hello?
Hey, yo, Gabriel. I'm making this pen and I just need your help with the material selection.
Okay, Giannis. I think you should lay down some functional geometrical constraints and requirements.
The nib must allow ink to travel from the ink chamber to the tip of the pen in a controlled manner, and the nib must sustain loads suitable for long-time use.
Okay, sounds good.
Oh, and the geometrical requirements are that the nib must be compatible with the size of a regular pen, and the slit of the nib needs to be wide enough to allow ink flow and expand when writing. You got that?
Okay, sounds good. Okay, so in terms of material properties, what are you trying to get at?
Yeah, so based off of the requirements I've told you, I want a pen that has a good strength to density ratio, and also it's stiff enough not to bend when I use it.
Okay, sounds good.
To fully analyze the nib, some of its geometrical properties were assumed. The ideal nib's moment of area and volume were calculated on the assumption that the nib's shape was roughly a rectangular prism. It was also assumed that at this small volume, the shape of the nib undergoes similar geometric behavior to that of a beam.
In order to narrow down the selection of materials that we had, we developed an MPI equation. So for starters, we had a cost objective equation, which relates the volume of the material that we use multiplied by the density of the material. In addition to that, we also had a mass equation, which relates the density of the material multiplied by the length, width, and height. We subbed the mass equation into the cost equation, and from there, we were able to develop an MPI equation. After that, we graphed the slope of the line over an axis of a plot of the density of the materials, and as well as the price of the materials. From there, we were able to eliminate some options.
So for this MPI, we developed an equation for the cost, which is cost is equal to price per volume multiplied by the volume. We substituted one of the volumes in for length times width times height. And then we found the equation online for buckling, which is this one, where FCR is the maximum force required for buckling. And then isolating for one of our free variables, which is length, we equated the two equations and then came up with this equation. And then rearranging, we found our MPI, and using that MPI, we plotted our X and Y axes being price per unit volume and X axis being Young's modulus. We also solved for the slope and the y-intercept, which gave us this. And so all the materials under the line satisfy what we're looking for this MPI.
In the last MPI, we're trying to relate cost and stiffness of our material. So we used this developed equation for cost and this stiffness equation we found online. After solving for L in the stiffness equation and subbing it into the cost equation, we were able to form our MPI. After graphing that MPI using the EduPack, we were able to see that these grade L materials would be removed from material selection.
After deriving the MPIs and removing materials not valid, we still had a few number of materials remaining. In order to further remove some of the selection that we had, we thought about the manufacturing process. For example, materials that were unable to be refined to very thin thicknesses, such as concrete, were removed because they would not be suitable for application of fountain pen nibs. Also, materials that would absorb ink, such as wood, were also removed. Our MPIs did not take this into account and were thus removed from our selection process.
So, Professor Chirico, what should we use?
Well, based on this graph, we should use
Carbon steel 1050.
because our MPIs have removed everything else.
Okay!
When thinking about the uses of
Carbon steel 1050.
in aspects outside of our MPI ratios, we think about how
Steel.
it reacts in corrosive environments. So on the EMF equation scale, or the EMF chart, we can see that
Steel.
it's very likely to oxidize in environments where there is a very strong cathode. So in a sense, if our nib is ever exposed to these environments, we'll realize that
Steel 1050.
will corrode. Something that our MPIs don't take into account.
Yo, Gabe, the most commonly used material, which is gold, does fit most of our requirements, but it is far too expensive compared to other materials that we can get.
At the end of the day, I think why people use gold is because it's nicer, it looks better, it's fancier. While at the same time, gold does meet all of our MPI requirements. However, it is more expensive and we don't really want that in our evaluation. So it might be more worth it to pay for it just so it looks nicer.
It undergoes an aging heat treatment. Let me just check how long it lasts. Aging temperature.